Today's video is on section 3.5, solving systems of equations. First, we're going to talk about substitution. So what you want to do is solve one of the two equations for one of the variables. Check that the variables have a coefficient of 1. For example, the y here has a coefficient of 1. So we'll solve for y. So we'll take and subtract the 3x. And then divide by -1. So we get y equals 3x plus 6. So then what we'll do is we'll take that 3x plus 6 and we'll substitute it in for the y in the other equation. So that's the wrong equation. Sorry about that. We'll take and substitute it in to the y in the other equation, right there. So 2x minus 4, equals -4 times 3x plus 6 plus 8. So notice when you substitute, you always want to put what you're substituting in parentheses so you understand that you're going to have to distribute. So now notice we have one variable. We have an x. So we can solve the equation for that variable by distributing negative 12x minus 24 plus 8. Combine like terms. So you get minus 16. Add the 12x. So you get 14x equals negative 16. Divide by 14. So you get x equals negative 16 over 14, which reduces to negative 8/7. Then you're going to take your value here and substitute it in for the x in one of the two. I'm going to choose the second equation to substitute it in for. So I get 3x, I get 3 times negative 8 over 7. Sorry, having a little technical difficulties here. The computer's a little bit behind my pen. Eventually it'll catch up. Okay. So negative 8/7 minus y equals negative 6. So then when you multiply, you get negative 24 over 7 minus y equals negative 6. Get rid of the fraction by multiplying by 7. So it's negative 24 minus 7y equals negative 42. Add 24 to both sides. So you get negative 7y equals negative 18. Divide by negative 7. And you get y equals 18 over 7. So our 2 points are negative 8. Our coordinate is negative 8/7 for x, and our y coordinate is 18/7. Those are the x and y values that will work in both equations. So next, we'll talk about elimination. So elimination, So in order to eliminate, we want to put both equations into standard form, if they are not already. So notice equation 2 is in standard form, but equation 1 is not. So let's put equation 1 in standard form by adding 4y to both sides. So we get 2x plus 4y equals 8. So notice we have both equations. We have 2x plus 4y equals 8. And we have 3x minus y equals negative 6 in standard form. So now what we're going to do is multiply in order to get the opposites of one of the variables. Now the easiest one to get the opposite would be the y's, because it's already 1 plus and 1 minus. So what we're going to have to do is multiply the top by 1 and the bottom by 4. When we multiply the top by 1, we get 2x plus 4y equals 8. The bottom by 4 gives us 12x minus 4y equals negative 24. And we're going to add down. So you get 14x. When you add down here, it eliminates the y's, because 4 plus negative 4 is 0, and it's equal to negative 16. Divide by 14, now in part 4, and we get x equals negative 8/7. So once we get x equals negative 8/7, then what we can do is we can substitute back into the original equation. So remember, 3x minus y equals negative 6. So 3 times negative 8/7 minus y equals negative 6. So negative 24 over 7 minus y equals negative 6. Multiply by 7. Add 24 to both sides. So you get negative 7y equals negative 18. Divide by negative 7. And you get y equals 18 over 7. So the answer is x is negative 8/7. Y is 18/7. There's our x and y coordinate. So that's substitution and elimination. So now some special cases. The first one we're going to talk about when it moves down is when we eliminate and the x's and y's cancel out. So here it goes. So in order to eliminate here, let's say we eliminate the x. So we'd have to multiply the bottom by 3 and the top by 2. Now because they're both positive, we have to multiply one of them by a negative. So let's make the top negative 2. So it's negative 6x minus 12y equals negative 42. Then the bottom one is 6x plus 12y equals 30. So then when we add down, notice both of the x and y's cancel out. So we have 0 equals negative 12. And notice this is not a true statement. Therefore, there's no solution. So the next one, notice we have x plus y equals 4y plus 2. So if we want to do elimination, let's get it in standard form. So x plus y equals 4y plus 8 when we distribute. And then we'll move the 4y over. So x minus 3y equals 8. Then the same can be said for the next one. When we distribute the 2, we get x minus y equals 2y plus 8. So then we subtract 2y. So we get x minus 3y equals 8. So both of them, notice, are the same. But let's say we didn't recognize that right away. So let's say we put them, here's equation 1, here's equation 2. we put them one on top of the other, and we decided to do elimination. So we multiply, to get rid of the x, we multiply the top by 1, the bottom by -1, let's say. Because they're both the same sign, so we have to do one positive, one negative. So we have x minus 3y equals 8. Negative x plus 3y equals -8. Notice when we add down here, everything cancels out. So we get 0 equals 0. This is true. And whenever you have the same thing, basically, it means you have an infinitely many solutions. Which means it's basically the same line. So now, it says if the system is infinite, we're going to give 3 solutions. So to give 3 solutions, we're just going to choose values for x. So let's say if x equals 0. So if x equals 0, I just say negative 3y equals 8, divide by -3, so y equals -8 thirds. So 0 and -8 thirds is one solution. Let's say if x equals 1, so we're just choosing numbers for x. So 1 minus 3y equals 8. So then we subtract 1, so negative 3y equals 7. Divide by -3. So y equals -7 thirds. So 1 and -7 thirds are another solution. And then last but not least, let's say x equals 2. Well, if x equals 2, we can say 2 minus 3y equals 8. Subtract 2. So negative 3y equals 6. Y equals -2. So these would be our 3 solutions to the problem. All right, that concludes our video on section 3.5. Hope you find it helpful, and if you have any questions, please feel free to ask in class. Thank you.